The announcement today wasn't necessarily like brand new Kepler data.
No, they collected the data seemingly a long time ago. It seems to be a new way that they're doing of processing the data.
Yeah, which is potentially really good.
Yeah.
Seems awesome.
Yeah, and they can use that for future missions, that, these techniques. But it seems to have allowed them to identify, what was it, 1,284?
Something like that, yeah.
Planets. New planets. I'm pretty sure it's that. New planets, yeah.
Yes.
So some of which are, the majority seemingly are, gas
yeah, like large Jupiter sort of things.
And that may possibly because they are slightly easier to detect, but or more obvious anyway with the methods they're using.
Yeah.
But still, they found like 100 what they think are probably rocky planets. I mean, they don't know they're rocky for sure. They just know that they are the size that you would expect rocky planets to exist at. They're unlikely to be gas giants of those sizes.
Yeah, they can tell something about their mass, I believe, as well, from their orbit and everything.
Yeah, so it strongly suggests, I think, a lot of
so them. Like you can get density from that and say that they're probably not made of gas and all that kind of shit.
Yeah, and some of them are in the habitable zone.
Yes, which is cool.
So like 9 of them. 9 of
like 1,200 or whatever, roughly.
Yeah. Yar.
So that's pretty low.
Yeah. There's, 9. We don't know what it takes to how common an Earth type planet is, but if every time you have a rocky planet in the habitable zone, it ends up being an Earth, then
that's 9 more Earths.
That's pretty mental.
Yeah, that's pretty nuts.
But obviously, it might not be the case. It might be that Earth's very rare.
Yeah.
Even for a rocky planet in the habitable zone.
Yeah, that's the thing. We kind of discussed it last week. The habitable zone is fairly loose. It's sort of not clear how much that actually means, what that actually means in the context of...
No, I mean, it's useful for generally characterising the structure of solar systems, I suppose.
Yes.
In the sense that on a rocky planet, it's a zone in which you would probably have liquid water on the surface.
Yes,
that's useful.
Probably.
But it's just that the habitable zone may not exist exclusively in that region in the solar system. It may also be, as we're going to talk about, and we talked about last week, on like icy moons or like a Titan, maybe type moon, around a gas giant or around some other planet.
Yeah,
so it's not the be all and end all of where life might exist in the universe, I guess.
Yeah, sure. It's probably a good place to look for, as we said last week, for complex life, just because you can have a highly energetic biosphere and all that stuff.
Yeah.
But yeah, so it sounds like the Kepler volume, which is what they call just the part of the sky that it's looking at.
It's like a cone-shaped area. Isn't it? Sort of looking at.
Like a segment of that cone. It's quite far away.
Yeah.
It's really far away, actually.
It's
hundreds of light years, I believe.
Oh, I can't remember,
at least the outer reaches
of the
Kepler volume.
150,000 stars.
Something like that, yeah, that are captured in there.
Yeah.
So the whole idea of Kepler is to try and get a handle on statistics of planets around stars. So you take that like 150,000 stars and just extrapolate that to the whole Milky Way, basically.
That's what the Kepler mission is winding down now, really.
Yeah, sure.
And so that's going to be the end goal, is when they'll publish some sort of paper on it that explicitly details their projected predictions of the X types of planets in the different regions of the solar system, what types of stars are more likely to show these planets, that sort of thing, and try and make some estimates on what we might see generally in the Milky Way galaxy anyway.
If you look at you can see pictures of the Kepler volume drawn to scale on the Milky Way, and it's absolutely tiny.
Yeah, it's really small.
Which is crazy. You think that to extrapolate that to the whole Milky Way, but then of course you have to assume that the Milky Way is going to be homogeneous on certain scales, basically. There's not going to be like weird patches of just like over here there's totally different types of stars and planets than over here.
Well, there will be, in a sense, that so obviously there's arms and stuff of the Milky Way, and they're going to be concentrated in those arms where the stars are. And as you get to the centre, I imagine you're going to have different distributions of things. The stars will change in type. Maybe it will become less likely that you get habitable.
Yeah, well, there's a lot more radiation
there might be like a
generally.
habitable zone in a galaxy as such. So
yes, of course, yeah.
So as you get too close to the centre, there's going to be a lot of crap, a lot of X-rays, a lot of horrible stuff just blasting out from loads of black holes and all sorts of stuff. Yeah. So you don't want that.
But the idea is that what we see in the Kepler volume is largely representative of this part of the galaxy, like this sort of
this band
of the galaxy,
all those parts of the different arms.
Yeah.
So you can probably in the sense that you could probably make some sort of estimate taking those things that I just mentioned into account and give a value on how many of these types of planets exist, or what types of planets there are out there, maybe. So yeah, it's a cool little piece of information. Seemingly, again, like we said, just data they've had for a while, and indeed it's going to take a while to process all the Kepler data, I think.
Yeah, but it's a good news that they've got this way of doing, because previously
it's
all
doubled
the confirmed,
the amount of planets roughly that Kepler
the properly
had been,
confirmed ones. Well, the thing is, the properly confirmed ones before were confirmed by follow-up observations where they watch repeat transits. Which is why they've taken so long to properly confirm the 1,000 or whatever that had already been confirmed. Lot...
They don't have to do those repeat observations, though.
Yeah, that's the crucial thing about this
lot.
new data, is they don't have to do that anymore.
Yeah.
Basically, just... But they needed to do it originally, obviously, to now get to the point where they can be confident enough with the statistics to confirm them just from the Kepler measurements themselves.
So they've got a pattern they now know they can follow, because it's a reliable pattern. Exactly, they've tested it over and over again.
So hopefully Kepler will have data on all 150,000 of those stars. It's just been collecting light from them all, so just sift through it all. And
they found about 3,000 planets so far. I think we said that already. It was 150,000 stars. One of the scientists did say that she wasn't surprised. She wouldn't be surprised if there was one planet per star at least
one. Yeah.
And if we take that 3,000 for that 150,000, it seems like there's a lot left to go through, or a lot left to find. I don't know much about this, but again, I guess it's not surprising if there is more than one per star on average.
No, I mean, it would
an
make
accretionary
sense,
planetary where some types of small star probably don't have the same type of disk systems.
Sure, and there's probably circumstances where things get ejected from solar systems or whatever. But yeah, I mean, an accretionary disk is a massive amount of material, like way more than a single planet.
Yeah,
it's worth of material
generally. So you'd expect
either
multiple planets per star. For a star that has planets, maybe there's some weird version, like you said, that's been ejected, or they tend not to form them. But for stars that have planets, then you probably end up with quite a few planets per star.
Yeah.
On average.
Yeah.
So we'll see. We'll see in the coming years and months.